Such bad lighting. Let's try this way. Okay, so the concept, right? Okay, this concept of perfusion. When we think about perfusion, we think about the heart, right? So it's important that we know the flow of the heart, right? So that is something that I want you guys to remember and technically memorize. If you can't understand the process, you got to memorize it, right? Because it's important to understand what is happening normally so that when it breaks, you can identify why it broke, and how we need to fix it, right? So when we think about, let's see, will this work? Why do they never work? They work at home, and then they don't work here. Okay, so when we think about the heart flow, right, we think about, let's see, I had a little exercise for you guys. I guess we'll do it next time because we took some time for the exam. We think about the blood flow is coming from the superior vena cava and inferior vena cava into the right side of the heart, right, atrium, then through the valves into the ventricles, then it has to go up to the lungs, get oxygen, then come back down around to the right side of the left side of the atrium, through the valve to the left side of the ventricle, then out to the aorta, to the body. So the thing that I want you to understand is when we think about what can go wrong and how bad things can get, right? Atrial issues are going to be worse, are going to be not worse, but less problematic than ventricular issues. And it makes a little sense, right? Because from the atria to the ventricle is a very short distance. So if something goes wrong, it's not as bad. But if the ventricles get messed up, then it's going to be more problematic because the ventricles were taking it to the lungs and the ventricles are taking it to the body. So we're going to have a problem if we can't get oxygen to the lungs or we can't get oxygen to the body, right? So atrial problems are not good, right? But they're not as bad as ventricular problems. And we're going to see that as we talk about it, okay? So we remember that the heart has the pericardial, the parietal, the pericardium. There's this tough fiber. We remember that in order for any muscle to contract, you need that, the action potential. It's all or nothing. We remember that the heart has automaticity where it works on its own. Like if I take the heart out of the body and put it on a table, it will beat without any connection, right? So that it has its own electricity, its own conductivity, and it doesn't need any other connections, which we'll talk about, the SA node, the AV node, all of that, right? So the heart has that electrical system, and it also has the plumbing system. So when we talked about the flow from the superior and inferior all the way around till it gets to the body, that's the plumbing system. When we talk about the impulses that causes the heart to beat, that's the electrical system with the SA nodes, which we'll talk about a little further, okay? We also mentioned that just as the lungs had a little sac that allowed it room to move so it doesn't bother its neighbors, the heart has a similar one as well. And just as the lungs had a little fluid in that space to give it more ease and functionality, the heart does as well. And we'll talk about some problems that can occur. Actually, we did mention, right, that we can have problems with the heart because of the lungs, right? The fluid that accumulates in the parietal sac, right? It's the same idea of the fluid that is accumulating in the pericardial area, right? Pericardial space. Okay, so when we think of S1 and S2, what are we thinking about? The heartbeat, right? The lub-dub, right? So S1 corresponds to the closing of the mitral and the tricuspid valve during systole, and S2 is corresponding to the closing of the aortic and pulmonary valve at the beginning of diastole, okay? And when we think about systole and diastole now, what do we think about? We think about, what is systole? When you think of systole, you think of contraction, right? When you think of diastole, you think of relaxation. So the heart has to contract to excrete the fluid, the blood that's inside, and then it has to relax so that more fluid can accumulate so that it can start all over again, right? Then it kind of brings us to when we're going to study hypertension, what the top and bottom numbers are, right? Systole is a top number in hypertension, and diastole is the bottom number. So when we think of hypertension or when we think of blood pressure, right? If that top number is super fast, right? That's not great. But if the bottom number is super fast, that's even worse. Because it's one thing, I'm sorry about that noise. I think that's OB over there. They're delivering a baby. Right? So the bottom number now, if it doesn't have time to accumulate the blood, which means that's why the speed is not going to allow it to accumulate, that's even worse. So when we get to hypertension crisis where the bottom number is bigger, we worry more about the bottom number for that reason, because the faster it is means we're not going to accumulate enough blood to pump it out, right? And we could also imagine that eventually, if the top number is super fast, it will start affecting the bottom number, right? Systole will connect to diastole very closely, and sometimes eventually they'll affect each other, okay? But that's the idea. Systole top number, diastole bottom number. Systole means contraction, diastole means relaxation, okay? So when we think about the pulmonary, we talked about it in our previous class before our last exam. We said the pulmonary is where the oxygen is collected and, put into the blood. Blood comes from the right ventricles, goes to the lungs to collect oxygen. So that's why the lungs are connected very closely to the heart, okay? And if there's something that's wrong with the lungs, eventually it will affect the heart. And if something is wrong with the heart, eventually it will affect the lungs. We said if we have lung problems where we have hypertension, pulmonary hypertension, we can have cor pulmonale, which is when the heart has a problem because the lungs are not working properly, okay? And then the systemic, right? We also need to think about, okay, well, when we get to the electrical signal, that's one problem that can happen. But when we think of the heart, the valves work by opening and closing, allowing blood to travel from one compartment to the next into the body. But is that where the heart itself gets its blood? Not necessarily, right? The heart has its own system of getting blood, and that's from what? Starts with a C. The coronary system, right? So the heart has to have blood to keep it alive, and it's not getting it from the same blood that's being sent to the lungs and sent to the body. It has its own little I would say, like the blood comes from that area, shunts it to the coronary so that the heart can get its oxygen and its blood to thrive, like right?
Its own circulatory system.
Its own circulatory system, right? And so with that, we have to understand, well, if those coronary systems do not work, what's going to happen? Well, that's how we have the atherosclerosis issues, right? We have, okay, so we have the buildup plaque. So when we think about the atherosclerosis, right? What we think about is a person who's not eating properly, not moving properly, not doing the things that they should do, fat starts to accumulate in the lining of the coronary. And over time, that fat causes a blockage in the area where the passage of the blood should be. And that's not a good thing, right? So that's the system or systemic area. When we think about the coronary area, the coronary part of the heart is what we're talking about. The systemic is when we talk about the blood flowing from the arteries into the blood flowing from the aorta to the ventricles to the lungs, back to the aorta to the next ventricle to the body, right? So we have a pulmonary, heart is involved, collecting oxygen. We have systemic, where the blood gets collected, put into the heart, and then travels to the body. Then we have the coronary, where the heart itself has to be maintained and get oxygen and energy to survive, okay? Okay, so now the types of circulation. So when we think about circulation, right? When we think about systemic, and we think about how does every part of the body get its blood, and we think, so we have We mentioned the pulmonary circulation, we mentioned the systemic circulation, how they connect with one another in order to get every little section of the body to get oxygen. And this will help us to understand when we don't have tissue perfusion, when we have gas exchange problems, when our pulses are weak and we don't have oxygen getting to our toes, or this is why the circulatory system, the perfusion system is being affected, right? So when we check for pulses, we're making sure, okay, is the capillary system, is the circulatory system, is it functioning? Is it getting to the extremities the way it's supposed to? Is gas exchange happening? First, we know it has to happen in the lungs first, yes. Once it picks it up, it has to be able to deliver it to everywhere. Blood vessels are everywhere. They're in your eyes, they're in your toes, they're in your liver, they're in your every organ, right? So if something happens to the blood system, the circulatory system, we're going to have issues with every part of our body, right? And it starts with whatever organ, usually, let's say the brain, the heart, the kidney, right? These are the ones that are going to feel it the most, but every organ is going to be affected. So the oxygen concentration in blood within the capillaries of the lung is lower than that in the lung alveoli. Okay? Because of this concentration gradient, oxygen diffuses from the alveoli to the bloodstream. Carbon dioxide, which has a higher concentration in the blood than in the alveoli, diffuses from the bloodstream into alveoli. So this is like that diffusion system we mentioned when we were talking about pulmonary, right? So one area has more concentration and it diffuses to the one that has less concentration, and that's how the flow works. Okay, so let's talk about cardiac cycle and output. So we have the cardiac output. When we think about cardiac output, it is related to the amount of blood pumped by the heart per minute. Okay, I'm gonna have to go over there.